Let's do a very simple sum, a very interesting one. This is going to be in the form of an activity. We have a figure and we have some information here. Let's look at this information. It says that xy is parallel to AC given. 2 times ax is equal to 3 times bx given. And xy is given as 9. Then complete the following blanks to find the value of AC. Okay, so there are certain blanks given and we need to fill them up. Before we start filling this up, there is something which I want you to understand before you start learning and doing this sum, right? Now, remember, in a triangle, when you have a line parallel to a side, there are two things which you can do in the sum. You can either go for basic proportionality theorem, which gives you the ratio ax upon bx is equal to cy upon by. And the other option is you can prove the triangle similar, right? You know how we can prove the triangle similar? When you have a line parallel to a side, it's so simple, right? Because this line is parallel to this side, we know that this angle y and this angle c will be equal, pair of corresponding angles. And this angle b will be the common angle. That means you'll get both the triangles to be similar, right? By a test of similarity, which we are going to do in this sum also, right? But why? Let's understand. Because in the sum, they have given you the value of xy and they have asked you to find the value of AC. And there's some information about these sides. That means we are talking about the sides, corresponding sides of two different triangles. So you can have a relation between them only when there is a relation between the triangles. That means we need to prove these two triangles similar, which we are going to do in the sum. And once we prove the triangles similar, we'll get the ratio xy, right, that is AC upon xy is equal to AB upon BX. Now AB upon BX you need to search in the sum, and in order to get that we are starting the sum this way. Understand why we are doing this. That's very important. So when we look at the sum, they say that twice of AX is equal to 3 times BX. That is given to us. So they want in the form of ratio, that is AX upon BX, right? So AX upon BX. So BX comes here in the denominator. So 3 remains in the numerator here. And that 2 comes in the denominator here. Remember that. So we get AX upon BX is equal to 3 upon 2. But as I said, once we prove the triangle similar, as you can see it later there, I said you're going to get a ratio AC upon xy is equal to AB upon bx. AC we need to find, xy we have. That means we can only get the value of AC provided we get the value of AB upon bx. We are doing all these things at the start so that we end up getting the value of AB upon bx. Remember that. So that is why now we have that. But we have the value of AX upon bx. But we want AB in the numerator. Now when you look in the sum, you'll realize that AB is nothing but AX plus BX. What is that? AX plus BX. That means we need to do AX plus BX. Two ratios are equal and I'm saying I want numerator plus denominator. When two ratios are equal and if you want numerator plus denominator, what are we going to use? Componendo. That is the reason we are using componendo. So understand the reason why we are using it. That's more critical. So we write AX plus BX upon BX is equal to, on the right hand side it will be 3 plus 2 upon 2, and that is by componendo. Right? Understood? So now what do we get? On the left hand side, AX plus BX, as you can see in the figure, is nothing but AB. Reason is A dash X dash B, betweenness. And on the right hand side we get 3 plus 2, that is 5, and we get it as 5 upon 2. Right? So we got the value of AB upon BX is 5 upon 2. That will be marked as result number 1. Right? And as I said, we are going to prove the triangle similar. That is written here. And we know these two triangles are going to be similar by A test. It's very simple, as I said. Consider the bigger triangle, consider the smaller triangle. In both we have the common angle, right, equal, and then we have a pair of corresponding angle equal. That is why we get the triangle similar by A test of similarity. We got the triangle similar. Why we were doing it? So that we get the ratio, that is AB upon BX is equal to AC upon XY. Now AC upon XY. Right, AC we need to find. XY is known to us, so XY value we have written here 9, but we wanted AB upon BX. What is that? AB upon BX we just got. How much is that? 5 upon 2. So we substitute that value of 5 upon 2 there, right? And that is what we got from 1. Now isn't it easy to find the value of AC? So simple, right? Because 9 will go here, so it is 5 into 9, that is 45. And 45 upon 2, how much is that? 45 upon 2 is nothing but 22.5. So we get the value of AC as 22.5 units. That's the sum. That's the way you solve it. But understand, filling up the blanks here is very easy. But you need to understand why those blanks are given, why the sequence of the sum is given that way. That's very critical.